Welcome to Chapter in 10, your ultimate guide to mastering Class 7 chapters in just a few minutes. Hey, science explorers, ever wondered what makes our superheroes so powerful? It's heat transfer. Just like the sun, our planet's main heat source, our hero uses a concentrated form of that same energy to melt ice, showing how heat always moves from a warmer object to a colder one. In this chapter, we're diving into the amazing power of heat. Get ready to master the science behind the hot and the cold and understand the awesome ways heat shapes our world, from land breezes to a superhero's scorching touch. This chapter is divided into two parts, and this is the second part of our journey. Today we're diving deep into it through a fantastic Q&A challenge that will help you master this chapter. So grab your thinking caps, get ready to guess the answers, and let's spark our brains. Let us switch on our minds and see what we can discover. Let's start with a common object in our kitchen, the saucepan. A saucepan has two main parts, the body, where the food cooks, and the handle. My question is, explain what kind of material, a good conductor or a poor conductor of heat, each part is made of and why. Think about the job of each part. All right, let's look at the answer. This is a perfect example of using science for a practical purpose. A cooking saucepan uses two different materials for two different jobs. The body, where the food goes. This must be a good conductor of heat, like metal. It's a good conductor because its job is to quickly absorb the heat from the stove and pass that heat directly to the food, so it cooks fast. The handle. This must be a poor conductor of heat, or an insulator like plastic or wood. It's a poor conductor because it must stop the heat from reaching your hand. This allows you to safely hold and lift the hot pan without getting burned. Let's switch from conduction to convection. Convection is all about the movement of fluids, liquids and gases. My first convection question is, where is the most suitable place to fit a smoke detector in a room, on the ceiling or near the floor? Explain why. The best place is always on the ceiling. A smoke detector should be fitted on the ceiling. Smoke contains hot gases. We know that hot air is lighter, less dense, than cold air, so it naturally rises up towards the ceiling due to convection. Placing the detector on the ceiling allows it to sense the smoke immediately when it rises. Here's a true or false challenge based on what we just discussed. Heat transfer takes place in solids through convection. True or false? False. Heat in solids travels by conduction. Convection only happens in liquids and gases. Next, heat transfer through convection takes place by the actual movement of particles. True, the hot particles physically move up and the cold particles physically sink down. The movement of cooler air from land to sea is called land breeze. True or false? That's true. Land breeze happens at night when the land is cooler than the sea. One last convection question. Imagine heating water in a test tube. In setup A, you heat the water from the bottom. In setup B, you try to heat the water only from the top surface. Which setup will heat the entire amount of water faster? Explain why. The correct answer is setup A, heating from the bottom. The water in setup A, heated from the bottom, will heat up much faster. Heating from the bottom. Setup A. This works fast because of convection. The hot water at the bottom becomes lighter and rises, while the cold water at the top sinks down to be heated. This circular current quickly heats up all the water. Heating from the top. Setup B. This is very slow because the hot light water stays at the top. Since water is a poor conductor, the heat cannot travel down to the cold water easily, so only the top surface gets warm. Quick ones now. If you put ice cubes in a glass, where do the ice cubes get the heat they need to melt? The ice cubes get the heat they need from the warmer surroundings, the air in the room, your hand, or the glass itself. Heat always flows from a warmer object to a colder object, causing the ice to melt. If an incense stick is burning, in which direction will the warm smoke move? The smoke will move upwards. This is because the smoke is warm, and warm air is lighter and always rises due to convection. Now let's think about keeping things cold. Does putting a leaky cold lassi tumbler inside another tumbler keep the lassi cold for longer? Explain why. Yes, this method will keep the lassi cold for a longer time. When you place one tumbler inside another, a layer of air gets trapped between them. Air is a poor conductor of heat, an excellent insulator. This trapped air barrier prevents the heat from the warmer outside environment from easily traveling into the cold lassi, keeping it cool. Final two questions on temperature control in nature and buildings. Why are hollow bricks used to construct the outer walls of houses in hot regions? Hollow bricks are used because they trap a layer of air inside them. Hollow bricks are used to trap a layer of air inside their hollow spaces. Air is a poor conductor of heat, an insulator. This trapped air acts like a shield, stopping the intense heat from the outside from easily passing through the wall and entering the house. This helps to keep the house cool in the summer. Explain how large water bodies, like the sea, prevent extreme temperatures in areas around them. This is all about the difference in how land and water absorb heat. Large water bodies prevent extreme hot or cold weather because land heats up and cools down much faster than water. During the day, the land gets very hot. The cooler air over the sea blows towards the land, sea breeze, cooling the coastal area. At night, the land cools down very fast, but the water stays warmer. The cooler air from the land blows towards the sea, land breeze. This constant exchange of air keeps the temperature stable, preventing the land from getting extremely hot or extremely cold. Let's finish with our planet's water. Explain how water seeps through the surface of the Earth and gets stored as groundwater. Infiltration. When rain falls, the water soaks down through the soil and rocks. This process of soaking is called infiltration. Seepage. The water seeps down easily through soil that has large spaces between particles, like sand. Groundwater storage. As the water moves deeper, it fills the empty spaces, cracks and pores in the rocks and soil beneath the surface. This water stored underground is called groundwater. Aquifers. The layers of rock that hold and store this huge amount of groundwater are known as aquifers. Our very last question. The water cycle helps in the redistribution and replenishment of water on the Earth. Justify this statement. The statement is correct because the water cycle is the continuous movement of water on Earth. Redistribution. The cycle moves water from water bodies through evaporation, high up into the air, and then brings it back down as rain or snow, precipitation. This movement shifts water across the entire globe, which is the redistribution of water. Replenishment. The rain that falls flows into and refills, replenishes our rivers, lakes, and oceans. Crucially, it also seeps into the ground to recharge our groundwater sources. This ensures that our vital water sources are constantly being refilled and ready for use. Excellent work, everyone! You've tackled some tricky questions about heat transfer in nature. Keep exploring, keep questioning, and keep learning. This video is part of our comprehensive Class 7 Science Curiosity playlist, so make sure to check out the full series for more exciting lessons. Don't forget to like this video, share it with your friends, and subscribe to Chapter in 10 for more exciting lessons. See you next time.